right. Welcome back. It's been a long time since spring break and all that stuff. So, any questions, first of all, on the homework from the last couple of days? There were a few really challenging questions on areas of regular polygons and geometric probability. Any questions on that stuff? Yeah, go ahead.
Is that going to be on the test tomorrow or not?
It's not going to be, no.
Oh, are you gonna do it on Google Classroom?
No, the only reason that this week's assignments are on Google Classroom is because they didn't have Delta Math, like, topics on those things. So, okay. All right, so there is a test tomorrow. So let's just review what's on the test. This unit is all about area of plane figure. So have area of rectangles. So remember that that's just area equals length times width or base times height. Okay, then we have area of parallelograms. And this is the same formula. Okay, then we did area of triangles, but we did this in 3 different ways. We did it first just by using the normal formula, 1/2 base times height. Then we also did it by graphing points in the XY plane. Graphing XY plane. So remember, the whole idea here was if you have a triangle that looks like this, and you're trying to calculate its area, this graph looks like this, the whole idea is that you encompass it with a rectangle, and you take the area of the rectangle minus the area of the little triangles that you don't want to include. Everybody remember that process? And then the third way that we did area of a triangle is using Heron's formula. So remember, this formula is area equals the square root of S times S minus A times S minus B times S minus C. And S is the semi-perimeter, half the perimeter. A, B, and C are the lengths of each side. Okay. Any questions so far? Yeah, go ahead.
Can we go over a problem with the Heron's formula?
Yeah, absolutely. So, for example, if we had something like, we have a triangle that looks like this, and its side lengths are 11, 7, and 8. Okay, the first thing you do is you calculate the semi-perimeter. So the perimeter is 11 plus 7 plus 8. So this would be 18 plus 8 is 26. And so the semi-perimeter is 26 divided by 2, 13. So then the area of this triangle would be the square root of 13 times 13 minus 11 times 13 minus 7 times 13 minus 8. And that's all there is to it. Then you just do this on your calculator. So you can do it all at once on your calculator. You can use Desmos diagonals or whatever, it would be the square root of 13 times 13 minus 11 is 2, times 13 minus 7 is 6, times 13 minus 8 is 5. And that's it, the square root of that whole product. It ends up being 27.928, and they'll tell you to round it to whatever. So if it was to the nearest tenth, this would be 27.9. Units squared. So if these were like all inches, remember in any of these problems, the units are squared. You're calculating area. Okay. So then we did area of trapezoids. So this formula, remember, was 1/2 h times b1 plus b2. So h is the perpendicularly measured height. B1 and B2 are the length of the top and the length of the bottom. In any order, you could, B1 could be the top or B1 could be the bottom, and then B2 is the other one. Then we did area of a rhombus. What's the formula for that? Anybody remember? Yeah.
Right.
Yeah, sure.
A half, D1 times D2.
Yeah, yeah. Right? You multiply the diagonals together and you divide by 2. Okay. Then we did area of a circle. So this was area equals pi r squared. And we also talked about circumference of the circle. So here the formula is circumference equals 2 pi r or pi d. Same formula. And remember, there were some problems in Delta Math where they gave you the circumference and asked you to find the area, or they gave you the area and asked you to find the circumference. So you have to be able to solve problems like that. There are two-step problems. You have to first figure out what r is, then plug it into the other formula. Everybody understand what I mean by that? And then the last question was area of a sector. Remember, a sector is just like a slice of pie, a circle. So it would be the angle, central angle, let's write it out. Central angle divided by 360 degrees times pi r squared. Right? So you're basically calculating some fraction of an entire circle. The fraction of the entire circle that you're including would be central angle divided by 360. Okay? And then the final topic was just composite areas. So these are not basic areas, but you can calculate their areas by adding or subtracting basic areas. And like an example was like the area enclosed by the track or something. That's really just a rectangle with 2 semicircles or something like that. Okay, so there's a lot of formulas here, but like always, this is open note. So there's really not a lot of pressure. You can just write this stuff down and refer to it, okay? But you have to know how to use the formulas. Any questions on that stuff? That's really all I have for today. The assignment is already posted on Google Classroom, and it's just a review assignment dealing with, it's really just old Regents questions that have to do with area. That's all it is. Okay? Any questions? Okay, so there's no live or recorded lesson tomorrow for those people that are at home. Just make sure you take the test sometime between 8 a.m. and 8 p.m. And the test corrections will be posted tomorrow night, and they're due Monday, like always. Okay? All right, I'm going to stop recording.